Good day, everyone. I am Ricardo Valenzuela Jr., a junior environmental biology student from the University of Santo Tomas. In behalf of my co-author, Justin Daniel Calizo, and our advisor, I will present our poster entitled Fish Otolith Analysis in Asia, expanding its taxonomic roots to more ecological targets. First of all, let's talk about otolith. What is this structure? Otoliths are tiny structures also found in fishes located in their inner ear cavity. Similar in bones, they are composed of fully calcified calcium carbonate. The fish uses it for orienting themselves and maintaining balances as they swim through the water. Scientific studies utilize this structure starting from its original taxonomic roots, which now expanded towards more ecological targets, which includes a variety of studies such as age determination, migration, life history, population studies, and stock management. The structure that can be studied are composed of three types in the vestibular labyrinth: the lapillus, asteriscus, and sagitta. They are paired, consisting of left and right structures for each type. To further understand on what topics these researchers focus on their otolith studies, we consolidated key published literatures on fish otolith in Asia to determine potential gaps and recommend future targets for research. We data mined these from published primary research articles found in the scientific search engines such as Google Scholar and ScienceDirect using targeted keywords. They were organized based on their research topics and transformed it to a graph to show the trends of studies. In this figure, it shows the distribution of the 91 studies collated. The microstructure studies has the highest count of 33 published papers, followed by 31 papers for microchemistry, 11 for morphology, 9 combined studies, and 7 morphometrics. But what do these research topics tell us? First, the microstructural analyses are used for age determination and early life history. These are known by looking and counting at the growth ring increments in the otoliths. Microchemical analysis deals with the movements and natal origin of fishes and migratory trace elements and stable isotopes in the otolith. Strontium to potassium ratio is commonly used in this study. Morphometrical uses shape indices of otoliths to study fish variation of their size structure based on their ontogeny and by comparing fish to otolith growth relationship. And morphology for species identification that is used for taxonomy. Going back to the taxonomic roots of the otoliths, the use of this structure is truly remarkable, as one study shows that otoliths can identify 80 to 85% of the fish families using the sagitta part that displays a high specificity for families of species, and therewith provide a means of identifying fish species. One of the interesting studies is that they were able to use the fossilized otolith found on the deposits way back in the Pliocene to gelation ages. This is due to its chemical composition that does not degenerate when treated under stressful conditions compared to other structures, such as scales. Hence, this can be also used in gut analysis for the feeding patterns of excellent predators, archaeological research, and paleontological studies. To sum it up, although many of its studies lean on ecological targets, otolith taxonomic analysis has an edge for species identification without needing the actual organism morphology and molecular samples. All in all, this otolith research will definitely progress hereafter. That is all for my presentation today. Thank you to all audiences for listening. Always take care and have a good day.